There is a face carved in stone beside the Nile, and for centuries, people assumed they knew who built it. Then scientists opened the tombs with a different kind of instrument, not a brush, not a chisel, but a sequencer, and the story stopped being simple. For generations, the ancestry of ancient Egypt was treated as something almost self-evident, argued over in classrooms and documentaries with more confidence than the evidence actually allowed. Some insisted the pharaohs belonged unmistakably to one region. Others insisted just as firmly on another. Both sides spoke with certainty. Neither side, it turns out, had the data to justify it. Then researchers began testing skeletal remains and later, genetic material recovered from Egyptian mummies, some of them thousands of years old. What they found did not hand a clean victory to any of the old arguments. Instead, it revealed a population shaped by geography, trade, migration, and time in ways far more intricate than any single label could hold. This is the story of what actually happened when science looked closely at the bones and DNA of ancient Egypt, and why the real answer turned out to be more interesting than the argument itself. For most of the modern era, the popular understanding of ancient Egyptian origins came less from genetics and more from geography, art, and inherited assumption. Egypt sits at a crossroads, the northeastern corner of Africa, bordering the Sinai Land Bridge into the Levant, connected by the Nile to territories stretching deep into the African interior, and linked by the Mediterranean to Europe and the Near East. Early 20th century scholars, working with the limited and often biased tools of the time, proposed various origin theories, many of them shaped more by the politics of the era than by rigorous evidence. Some argued for a Near Eastern founding population. Others pointed toward deep African roots. Still others suggested Egypt developed largely in isolation. Skull-shape studies, a method called craniometry, popular in the 1800s and early 1900s, were used to support ancestry claims. But the technique carried serious flaws, deeply entangled with the racial pseudoscience of that period. By the mid to late 20th century, archaeology and Egyptology had moved past those crude craniometric ideas, favoring cultural and historical evidence instead. But the underlying question, who biologically were the ancient Egyptians, remained largely unresolved, sitting quietly in the background while newer, more objective tools slowly developed. Those tools were about to change everything. The first hints that something more complicated was going on did not come from full genome sequencing. They came from something more basic, skeletal morphology, examined with modern statistical rigor rather than 19th century assumption. Researchers using updated craniometric methods, measuring bone structure across large samples with careful statistical comparison, rather than the crude racial typologies of the past, began noticing something unexpected. Ancient Egyptian skeletal remains did not cluster neatly with any single modern regional population. Some samples showed closer statistical affinity to populations in the Near East and Eastern Mediterranean. Others, particularly from southern regions of Egypt near Nubia, showed patterns pulling toward populations further south along the Nile corridor. This alone was not shocking to specialists. Egypt's geography practically guaranteed some degree of regional variation, but it complicated the simpler narratives being repeated in popular discussion. If the population was not uniform, and if its closest statistical affinities shifted depending on time period and region, then any claim of a single, clean ancestral identity was already on shaky ground before genetics even entered the conversation. The bones were suggesting complexity. DNA would be needed to test how deep that complexity actually went. Ancient DNA analysis is difficult under almost any circumstances, but Egypt presented a particular challenge. Egypt's climate, hot, dry, and in many burial contexts further altered by the chemical processes of mummification, is notoriously hostile to the preservation of genetic material. Heat accelerates the breakdown of DNA, and for decades, many researchers assumed that reliable ancient Egyptian genomes might never be recoverable at all. That assumption changed in the 2010s, when a research team focused their efforts on mummified remains from Abu Sir el Melek, a site along the Nile with burials spanning roughly 1,300 years, from around 1400 BCE to 400 CE, reaching from the New Kingdom era through the Ptolemaic period and into Roman era Egypt. using improved extraction techniques, and crucially, working primarily with mitochondrial DNA, genetic material inherited along the maternal line, which survives in far greater quantity than the full nuclear genome. The team successfully recovered genetic data from dozens of individuals. This was a breakthrough not just in terms of what it found, but in terms of proving it could be done at all. For the first time, researchers had a genuine dataset drawn directly from ancient Egyptian remains, rather than inference, artistic interpretation, or outdated skull measurements. What the mitochondrial data showed surprised many observers, precisely because it did not confirm either extreme of the old popular argument. The ancient individuals sampled showed genetic affinities most closely aligned with populations of the Near East and Eastern Mediterranean, the Levant in particular, more than with populations from sub-Saharan Africa. This pattern held with notable consistency across the 13 centuries the sample spanned, suggesting a degree of genetic continuity in the studied population through multiple periods of Egyptian history, including eras of foreign rule. That finding did not sit quietly. It reopened old debates, some of them driven more by present-day identity politics than by careful reading of the science. But something crucial tended to get lost in the noise. The study's authors themselves urged caution, and for good reason. If you find this kind of evidence-driven history compelling, where the truth turns out to be more careful and more complicated than either side of an old argument, this is a good moment to subscribe, because untangling these stories carefully is exactly what this channel is built around. The caution mattered because the picture the DNA painted was not finished. It was, in several important ways, just beginning. First, the sampled remains came from a single site in northern to Middle Egypt, a region historically more connected to Mediterranean and Near Eastern trade networks. Southern Egypt, closer to Nubia and the deeper African interior, was not represented in that dataset at all. A population's ancestry can vary significantly by region, especially in a country as geographically elongated as Egypt, stretching along a single river for close to 1,000 kilometers. One site's genetic signature could not be assumed to represent the entire ancient population, from the delta to the southern border. Second, and just as important, mitochondrial DNA tells only the maternal line story. It says nothing directly about paternal ancestry, and it captures only one lineage per individual out of a vast, branching family tree stretching back generations. A fuller picture would require nuclear DNA, the complete genetic blueprint inherited from both parents, which is far harder to recover from remains this old, particularly in Egypt's punishing climate. And there was a third layer buried in the data, one that many casual summaries of the study skipped entirely, but which turned out to be one of the most significant findings of all. When researchers compared the ancient samples to Egyptian populations living today, they found something that did not fit a simple continuity story. Modern Egyptians, on average, carry a noticeably higher proportion of sub-Saharan African ancestry than the ancient individuals sampled from Abu Sir el-Melek. That was not a footnote. That was the twist. It suggested that a meaningful shift in the genetic makeup of the region occurred sometime after the Roman period, likely across the last 1,500 years, potentially tied to increased trans-Saharan trade routes, the Nile's use as a corridor for later migration, the Islamic-era expansion of long-distance commerce and mobility across Africa, and centuries of demographic change that followed the era the ancient samples were drawn from. In other words, the DNA was not simply confirming which ancient civilization Egypt belonged to. It was revealing something more dynamic, a population that shifted over time, shaped less by a single fixed origin and more by an ongoing, layered history of contact, trade, and migration stretching across thousands of years, both before and after the era of the pharaohs. Researchers have proposed several frameworks to interpret this layered picture, and it's worth holding them side by side rather than picking a favorite too quickly. One framework emphasizes continuity from a Near Eastern affiliated founding population, established early in Egypt's pre-dynastic period through contact and possibly migration across the Sinai and the Fertile Crescent, with strong genetic persistence across many centuries of subsequent Egyptian history. A second framework highlights regional diversity as the primary story. The idea that Egypt was never one single population at all, but a corridor society, with northern regions leaning toward Mediterranean and Near Eastern affinities and southern regions, near Nubia and beyond, carrying stronger genetic ties to populations further along the Nile and into the African interior, essentially from the beginning of recorded Egyptian history. A third framework centers on later admixture. The idea that the sub-Saharan genetic increase visible in modern Egyptians reflects centuries of post-ancient contact, driven by trade networks, the movement of enslaved and free populations across historical trans-Saharan and Nile routes, and the broader connectivity of Egypt as a crossroads civilization across the medieval and early modern periods. These frameworks are not necessarily in competition. Many researchers now suspect the real answer involves elements of all three: a population that was regionally diverse from early on, culturally distinct in the north versus the south, and further reshaped by later migration long after the age of the pharaohs had ended. The landmark 2017 study on the Abu Sir el-Melek mummies remains the most direct genetic window into ancient Egypt to date, precisely because it combined a large multi-century sample size, rigorous ancient DNA contamination controls, and direct comparison against both ancient and modern reference populations. Its authors were explicit that their findings applied most confidently to that specific site and time span, not to the entirety of ancient Egyptian civilization across 3,000 years and 1,000 kilometers of river valley. That kind of scientific restraint is not a weakness in the study. It is exactly what makes it credible. Here is the twist worth sitting with. The old public argument assumed there had to be one correct answer, that ancient Egypt was essentially one thing, and the only real dispute was which thing it was. The DNA suggested something almost the opposite. Ancient Egypt likely was not one static population at all. It was a long-standing crossroads civilization, and the genetic story of the region shifted meaningfully across different eras, driven by trade, geography, and time, in ways that resist being collapsed into a single modern category. Not simply which ancient civilization matched Egypt. Instead, how much movement, contact, and layered ancestry sat underneath a culture that outsiders have spent centuries trying to sort into one tidy box. Why does that matter beyond the specific case of Egypt? Because it exposes something true of nearly every ancient civilization built along a major trade corridor. Population history rarely follows the clean lines drawn by later political or cultural narratives. Egypt sat where Africa touches the Near East, along a river that connected the Mediterranean to the deep interior of a vast continent. A civilization built in exactly that location was always more likely to reflect centuries of contact and exchange than a single unbroken bloodline preserved in isolation. Modern genetics does not diminish ancient Egypt's achievements or its complexity by revealing this. If anything, it restores something the old rigid categories had erased. A civilization built not despite its position at a crossroads, but in part because of it. Picture the Nile as it would have looked to those ancient communities. A single green ribbon of life cutting through a vast expanse of desert, boats moving cargo, and people between Nubia in the south and the Mediterranean ports in the north, caravans crossing the Sinai carrying goods, ideas, and unions between families from different regions. Picture temple walls carved with processions of tribute bearers from foreign lands, workshops where craftsmen from different backgrounds work side by side, and marketplaces where languages from 3 continents would have mixed in the same square. This was never an isolated valley. It was one of the ancient world's great intersections, and its people, biologically as well as culturally, appear to reflect exactly that. If this kind of careful, evidence-based unpacking of ancient identity is the kind of history you want more of, let me know in the comments which civilization's DNA story deserves the same treatment next. What the science ultimately suggests is not a simple correction of one old myth in favor of another. It is something more honest, and in some ways more remarkable. Ancient Egypt was not a single fixed identity waiting to be correctly labeled. It was a living, shifting population, shaped over thousands of years by geography, trade, migration, and contact. A story written not just in temple inscriptions and royal genealogies, but quietly preserved, layer by layer, inside the genome itself. The old arguments wanted a clean, final answer. The evidence offered something far more textured instead. A civilization built at the meeting point of continents, whose people across 3,000 years were never quite as simple or as singular as either side of the old debate assumed. The pyramids still stand exactly where they always have. What changed is our understanding of the people who built them, not smaller, not simpler, but layered in ways that only careful science, applied with patience and restraint, was ever going to be able to reveal.